Good evening, students. Today we will learn about kinetic energy. So, in this class, we will discuss about what is kinetic energy and in which bodies this kinetic energy will be stored and what is the expression of this kinetic energy. We will learn here. Okay. So, first of all, see the definition. The energy possessed by a body by virtue of its motion is called kinetic energy. So the meaning of this definition is the bodies which are in motion, all the bodies are having the kinetic energy. So once again I will repeat it. The bodies which are in under motion, that all the bodies will have some type of energy. That energy we can say it as a kinetic energy. So simply we'll see a few examples here. So for example, take one example here. So a vehicle is moving on a road. So one vehicle is moving on a road. So if the vehicle is moving on a road means vehicle is in under motion. So whenever the vehicle is moving on the road, so it will have some energy. That energy only we can say it as a kinetic energy. Otherwise, a water is flowing on a river. So water is flowing on a river. So whenever water is flowing on a river, so what is the meaning of that? Water is in under motion. So whenever water is in under motion, it will have some energy. So that energy also we can say it as a kinetic energy, because in the first example vehicle is in under motion, second example water is in under motion. So both objects are in motion. So whenever the objects will be in motion, so it will have the kinetic energy. Okay, so I hope you understood about kinetic energy. So we will derive the formula for the kinetic energy. Okay, so now to derive the kinetic energy, I'll take one example here. Consider one object is here, its mass is m and its initial velocity is 0. That means object is in rest position. So now I applied some amount of force on this block. So whenever I applied some amount of force on this block is moved from here to here, and when the block came here, the mass is m only, because mass will not change because of the force. So velocity is v. Okay, now the object covered, this block covered s displacement. Now, so what is the work done formula? As per the work done formula, whenever we applied some amount of force on the body, it will displace, means what is the meaning of that? Some amount of work is done there, right? Because of the force, one body is moved from one place to another place, means we can say there some work is done, right now. So whenever we applied F force, it is displaced from here to here. That means S displacement. Okay, so what we have to understand here some work is done. So we are taking the work done now. First I will find the work. So work done is equal to, as we know from the previous lectures, work formula is what? Dot product of force into displacement. So dot product means what we have to write? Fs cos theta. Here what is the angle? Theta means angle between F and S. So see the diagram. We are applying the force on the block right side. When we applied the force on the block right side, body is displacing right side only. So both force and displacement both are in the same direction. So that means like this, force displacement both are in the same direction. So angle is 0. Now please substitute here. So work W is equal to Fs cos 0. Cos 0 means 180. So work done is equal to Fs. Okay. Now let us use Newton's second law here. Newton's second law. F is equal to ma. So please take this, give the equation number as 2, put 2 in 1. So W is equal to, in the place of F I am substituting ma, s. So okay, give equation number 3. Use kinematic equation. So see which kinematic equation we have to use in the diagram. See what are the terms are there: u, s, v. Okay, so whenever we applied some force on this block, it will move with some acceleration a. So here u, a, s, v, four terms are there. So related to these four terms, which kinematic equation will be available? V square minus u square is equal to 2as. Okay, so v square is v square, u value is equal to 0 from the diagram, so I will substitute here. 0 square is equal to 2as. So v square is equal to 2as. So please keep a in this side, bring this 2s this side. A is equal to v square by 2s. Please substitute this a value in equation 3. So work done is equal to m v square by 2s into s. S cancel. Work done is equal to m v square by 2. Okay, so this work done will be stored in the form of kinetic energy in this block. So in this block, work only will be stored in the form of kinetic energy. Okay, so this work only we can call it as a kinetic energy. So half m v square. Okay, this is the explanation about the kinetic energy. Thank you.